Hello everyone. Today we are going to see how to build a simple AI agent using Phidata library. So Phidata is a powerful open source platform which is designed to simplify the creation and deployment and management of AI agents. So we can build domain specific AI agents equipped with memory, knowledge, tools and which enables them to perform complex tasks seamlessly. So it can support OpenAI models, Cohere models, Grok models, and many other open source models also. And it integrates easily with popular vector databases like Postgres, PG Vector, Pinecone, and open source databases also. Also, we can get structured outputs, we can get reasoning capabilities, and real-time RAG or retrieval augmented generation pipeline in Phidata. So it offers all the essentials tool to build and scale and manage intelligent agents efficiently. In this tutorial, I am going to walk you through a step-by-step guide to build your first AI agent using Phidata. So first, we need to install the required libraries. So using pip install command, we are installing this required libraries. So if you run this cell, it will install all the required library, the Phidata, Grok for the LLM, and OpenAI and other libraries it will install. So here we will be using Grok API for our LLM access. So if you run this cell, it will ask you for the Grok API key. So to get Grok API key, you can go to the Grok cloud website where you can log in, and if you you can create your own API key. So here there will be option to go to the API keys section. When you go there, so you can create your API key using this create API key option. So here you can name the API key. Let's say I am naming it as Grok Pi Data. So once you click on it and submit it, so it will create the API key. So you can copy the API key and paste it here and click enter. So it will save the API key in your environment. So after that, so in PyData, to create the agents, there is a class called agent. So the core parameter are model, which specifies the language model the agent will utilize, and name assigns the unique identifier name to the agent, and description provides a brief overview of the agent's purpose, which can be included in the system message. And instructions defines a list of guidelines directing the agent's operation. And you can include memory to the agent and knowledge or external database to the agent. Also you can add external context. When set equal to true, the agent incorporates relevant context from its knowledge base into user prompts, enhancing response accuracy. And you can also include tools, so a list of functions or toolkits the agent can employ to perform actions like web search or data analysis, etc. So now we will see how to create a simple agent using this agent class in Phidata. So here we are importing this phi.agent, importing the agent class, and from phi.model.grok we are importing the grok model API. So here we are specifying the grok model we are gonna use. We are using this Google's Gamma 2 9 billion parameter model. So specifying the name. So you can go to the grok cloud, and if you go to this playground option, here you can select the model, whichever model you want to use. So let's say if I want to use this model, so if you click on view code, you can find the how to use this model. So here from here you can copy the model name and paste it in this code here. So here I'm using this. So here we are using this agent class, so we are giving the agent as a name of poem writing agent. So the role is a distinguished English poet who writes beautiful poems, and the model we are passing as this LLM, uh, which we defined before. An instruction that poem should sound cheerful. So you can provide any other instruction as per your requirements. And markdown equal to true means like the output will be in markdown format for better readability. So once you define the agent, you can uh, run it, or simply print the response using this as agent dot print response function and pass the prompt. So I am asking the agent to write a poem on rain, and stream equal to true means once you run it, the it will stream the output one by one. So if I run it again, so it will run it and it will give you the output. You can clearly see it has given us the output as a poem in a cheerful manner about rain. So in this way, you can simply build a simple AI agent as per your requirements. So you can provide any instruction, any role, any name, and the model you can define, and you can simply run the agent. So now we will see how to integrate tools into the agents. So in Phidata, tools are integral components that empower agents to perform specific actions and interact with external systems. So it extends their capabilities beyond standard language processing. So tool can be pre-built functions and or custom Python functions or comprehensive toolkits designed to work cohesively within an agent. So in Phidata, there are some pre-built toolkits, and also you can define your custom tools also using Python functions. So here we will create a simple web search agent within the Phidata agent class. So here we are using this DuckDuckGo search API for web search. So first we are importing from py.tools.duckduckgo, importing to the DuckDuckGo search function, and we are defining the LLM here, and we are defining the llama model for our LLM agent, and we are defining the web agent. Inside the agent function, we are giving the name as web agent. Role is to search the web for information, and model we are passing this LLM model we define. And here the tools, we are passing the name of the tool as a name of the tool or the instance of the tool in a list. So in this way, we can pass multiple tools also if required. So here we are using single web search tool. So we are passing a single web search tool in this list. And instruction always includes sources. So you can include other instruction also, but here we are including the instruction as that always to include the sources which it's citing in the response. And show tool calls equal to true, so it will show you all the tool calling done by the LLM, and markdown equal to true for the response readability. So when you run the web agent dot print response, and I'm asking about the latest news on Donald Trump, and if you run this again, let me run this again. So it is doing the web search. So first it has done the web search, and query was Donald Trump news, and maximum top results it taken has 5 by default. And then it has given us the latest news on Donald Trump, and it has given us the 5 key points, and also it has included the sources. So you can click on the sources and view the original articles also. Similarly, here we defined a single agent. Now if you want to define multiple agent together, we need to use agent teams. So we can combine multiple agents and create a team of agents which will work together to answer your queries. So here you can see we are importing the file.agent functions. Similarly as before, we are importing the web search tool and another tool called Y Finance tool, which can search for company stock information and financial information using your Yahoo Finance library. And we are importing the Grok model as similarly as before, and we are defining the LLM as Grok Llama 3.3 model. Here we are defining the web search agent, naming similar to the previously defined web search agent, and we are defining another new agent called finance agent, whose role is to get financial data about any company. And the tool we are given as Yahoo Finance tools, which will give us the stock price of the company and recommendations about the stock buy or sell option, and also company information. So everything it will give us. So here we are giving instruction that use tables to display the data also. So you can include other instruction like include sources, do some calculation or something like that. And show tool calls equal to true, it will show us the tool calls, and markdown equal to true for readability. Now here the important part. So here we are defining the agent team. So here we are defining the agent using the same agent function, but inside this new parameter called team. So here we are passing the list of agents we defined before. So we are passing the web agent and the finance agent in this list. So these two agents will work as a team now. So based on the user query, it will use both of these agents as per the requirements and give us the output. And we are providing the instruction as always include the sources and use tables to display data. And similarly, show tools calls equal to true and markdown equal to true, and we are passing the model similar to the Llama 3 model we defined before. Now, if you want to record the response and save the response in a variable, you can simply give it a name. So we are giving a response and agent team dot run, and I'm asking the agent to summarize analyst recommendation and share latest news for Nvidia stock. So ho- if I run this, so what it will do is that it will go to, so if I run it, it will go to the websites and give me the uh, latest information. So if I run it, so it will start doing the research for me. So this was previously run output. So here you can see all the details are there. So what content it has retrieved from websites and using Yahoo Finance tools. So all the prompt, total number of prompt and completion time, what was the session ID, and every all the information it is there. So what was the tool calls it has been using. So every detail of the whole process it is recorded in this response variable. So you can clearly see the details here. So if you want to print only the final response, you can use this uh, pretty print run response function from the utils module in Phidata. So if you pass the response to this function, it will print the response in a nice markdown format. So here you can see the agent has transferred the task to finance agent and summarize the analyst recommendation for Nvidia, and expected output is a summary of analyst recommendation, additional information, Nvidia stock ticker, and after that it has transferred the task to web agent and get the latest news for Nvidia, and expected output it has taken as the latest news for Nvidia, additional information, Nvidia stock ticker, and after that it has run the all the functions and get us the required information. Here you can see analyst recommendation for Nvidia. It has given us a data table. It has included the sources and latest news about Nvidia also it has given, and it has included all the sources also. So in this way, we can build simple AI agents, single agents or multi-agent system using Phidata. Hope you have learned something today about building AI agents using Phidata. Thank you.